Okay, we are just recording. So, okay, so welcome to everyone. So we will start our online lecture series. The title of the series, as you may know, is Smart, Pervasive and Mobile Systems Engineering. And the series was organized by me as chair of the Italy chapter of the System and Cybernetic Society. So I'd like to say that so far it has been pretty successful because we had many attendees, not only local ones, but also from other countries. For sure, all topics were very interesting, and also our speakers, are very interesting speakers, even very well known at the international level. Today we have Professor Pierluigi Siano, so it's a very pleasure for me to host his lecture. We met some months ago because we both share, I'd like to say, a kind of weight, international weight, because we are both a highly cited researcher by Web of Science. And we met just, for these, let's say, international nomination. And we had some discussion and also planning for some future joint research activities. So we both decided, to have this talk, and the talk, as you may see, is on scalable, privacy-preserving, distributed parallel optimization for residential prosumers in smart grids. This topic is receiving a lot of attention at the international level. Indeed, at the national one, we have different projects funded in a recent industrial-oriented research project framework that is called, in Italian, it's called PON. So we have several projects on this specific subject. One of such projects is coordinated by our university. I'm not involved in this project, but some groups from this university, and also some groups from the ICAR Institute, that is an institute belonging to the National Research Council of Italy. Such groups are involved in this project, and hopefully we will also have a member of this project from the university. Maybe he got some problem to join, but I hope that he could join later, even during the lecture. Okay, so I'd like just to say something about Pierluigi. So let me switch here. Okay, so okay, I already mentioned the title, so I will not read the abstract because Pierluigi will start soon his lecture. And I'd like to say that Pierluigi comes from University of Salerno, so he's professor at the University of Salerno, and he's also director of the Smart Grids and Smart Cities Lab with the Department of Management and Innovation Systems of University of Salerno. His research activities are pretty broad and mainly centered on demand response and the integration of distributed energy resources in smart grid. So this is currently his main research topic, even though, as I told you, he researched extensively in many research topics and lines. He co-authored many papers, as you may see, more than 500 articles in journals, mainly journals, conferences, international ones, of course, and currently his bibliometrics is pretty high, and notably he is a highly cited researcher by Web of Science. Maybe this is the most important recognition, bibliometrics recognition, okay, worldwide. And is also editor of several journals, important journals, like IEEE Transaction on Industrial Informatics and Industrial Electronics. They got a pretty high impact factors. And also he is leading as a chair several efforts, specifically technical committees in on smart grids. So Pierluigi, please, it's my pleasure and honor, you know, to pass you the floor. Okay, so please start your for sure very interesting lecture.
Thank you very much, Giancarlo. Good morning, everybody. Now I share my my screen. I'm very delighted to present this keynote at this virtual lecture series on smart, pervasive, and mobile systems and engineering. I'm very grateful to the organizers for inviting me, and in particular to Professor Giancarlo Fortino. Today, I'm going to present this keynote titled Scalable Privacy Preserving Distributed Parallel Optimization for Residential Prosumers in Smart Grids. In this keynote, after briefly introducing the procurement of flexibility resources in the ancillary services market, I will talk about an architecture for large-scale aggregation of prosumers that we have designed and developed at the University of Salerno in the context of an Italian pilot project. The architecture has been designed to allow an aggregator to participate in the ancillary services market for providing flexibility, solving both day-ahead and real-time optimizations. Then I will describe an innovative distributed parallelized linear programming based optimization that is scalable and privacy preserving, allowing to deal with hundreds of thousands of prosumers without disclosing their information. I will then present some results based on a real Italian pilot project. Then finally, I will present some findings and conclusions. As you know, future electricity distribution grids will host a considerable share of distributed and renewable energy sources, and the electric power system is undergoing a rapid transition toward decarbonization and decentralization. Residential and commercial customers that were once simply consumers of electricity are deploying distributed energy resources, becoming producers themselves in a new, increasingly decentralized power system. The flexibility offered by new resources and technologies can reduce, in fact, the electricity and infrastructure costs while enabling the power sector to meet decarbonization targets. Modern power systems are evolving from a centralized paradigm according to which electrical energy was mainly generated by large power plants at the transmission level to a new decentralized layered decomposition optimization model like the one shown in this slide, where distributed generation, often based on renewable energy sources, represents a relevant portion of the produced electrical energy. In this new model, the provision of ancillary services to the transmission system operator should take into account the possible flexibility furnished by new distributed resources, such as dispersed and small generators, and also based on renewable energy sources, and frequently endowed with small batteries. In particular, distributed battery energy storage systems, also of small scale, that were mainly used to decrease the uncertainties due to renewable energy sources and to increase the energy self-consumption for the end users, now can be also managed to provide energy flexibility to the transmission system operator. Battery energy storage systems can be directly managed by the system operator or controlled by an aggregator that can offer energy flexibility in the ancillary services market. Considering this new model of modern power systems and to exploit the potential of energy flexibility offered by new resources, the European regulatory framework has opened the ancillary services market to distributed energy resources, including energy storage and demand response providers. Among the many distributed energy resources, battery energy storage systems have gained recently more attention, mainly because of their higher rate and fast response. The proposed methods consider both the planning and the real-time sessions in the ancillary services market to respectively define the unit commitment and the activation of flexibility resources according to the Italian ancillary services market. Considering a pay-as-bid mechanism and a settlement period of 15 minutes, an aggregator, after carrying out a day-ahead optimization based on day-ahead forecasts, can offer services of flexibility in the up or down mode during the planning session, considering its baseline as a reference. If the offers are accepted by the system operator, it can ask the aggregator to deliver the flexibility provision during the real-time session. So, if the energy is not delivered by the aggregator, an imbalance cost is applied accordingly. The aggregator should carry out a real-time optimization based on a short-term forecast to not pay the imbalance cost. It is worth noting that in the last years, the Italian Regulatory Authority for Energy, Networks and Environment implemented a new regulation that allowed aggregated distributed energy resources to participate in the market for ancillary services. According to this regulation, an aggregate can be composed of different types of resources, including generators, loads, battery energy storage systems, electric vehicles, and so on, without any limit to the rated power of the single resource. But the aggregate must have an overall minimum regulating power that is now 1 megawatt, but in the future years it will be lower. So, in order to implement the proposed distributed parallel optimization and to allow the exchange of energy data among all prosumers, distributed intelligent devices based on information and communication technology should be used. It is thus assumed that all prosumers are endowed with a home device gateway, a smart meter, allowing near real-time communication of the energy data flow, and an energy management system, which is a hardware device, such as a Raspberry platform. A management system platform based on an information communication technology infrastructure and other software applications is also required for evaluating the absorbed and injected active power for all prosumers, and also for exchanging information between prosumers and for managing all the batteries. To consider the large-scale aggregation of prosumers can be managed by using the implemented layered architecture, where each energy management system can perform a local optimization. The layered architecture that is shown in this figure consists of a physical layer and a virtual layer where all prosumers can access. The physical layer provides grid connection, smart metering, all communication to all prosumers. The virtual layer includes an energy information system allowing local site awareness based on real-time monitoring and on tools for forecasting the photovoltaic production and load demand. By accessing to the virtual layer, prosumers can exchange only some privacy-preserving information, mainly related to their local optimal solutions and their power flexibility contribution to fulfill the global constraint of the global optimization problem, the 1 megawatt I talked before. The virtual layer is based on distributed ledger technology and on smart contracts to achieve both the day-ahead and real-time distributed parallel optimization while preserving the privacy of prosumers. The considered approach is based on a pilot project that we are carrying out in Italy for the procurement of flexibility resources in the Italian ancillary services market. In particular, in the day-ahead problem, the aggregator aims at maximizing the remuneration shown in this equation due to the provision of energy flexibility in the ancillary services market and minimizing the operating costs for all prosumers. For up and down regulation, the global constraints related to the minimum power in comparison with the baseline should be also respected. And some local constraints should be considered, including the power balance for each residential prosumer, the power limits for the grid for each prosumer, and the power charging and the discharging speeds of the battery. If the offer is accepted by the system operator, the aggregator should guarantee the provision of an amount of energy flexibility in the time ranges defined by the discrete variables obtained as a solution from the day-ahead optimization. The real-time optimization problem is obtained by the day-ahead one by fixing these discrete variables. And the same objective function is considered, but only in the time range defined by the discrete variables that are the final and the initial and the final for up and down regulation. As regards with the constraints, there are some equality constraints that are determined by the energy flexibility, that is this one that has been accepted by the system operator during the day-ahead phase. The same local constraints of the day-ahead optimization are considered. The real optimization can be carried out every 15 minutes to update the control signals for the batteries, to adapt to the changes of the photovoltaic production and electrical loads for each prosumer, considering that the proposed parallel optimization is very fast. Now, in order to determine the discrete variables, these variables can be identified during the day-ahead, both in a centralized way by carrying out a mixed integer linear programming optimization, and also in a heuristic way by using a new two-stage method based on hybrid variable neighboring search and distributed parallel optimization. This is because we prefer to use this second approach because the centralized formulation is not able to deal with extra large instances arising from real-world scenarios. By solving instead the problem in a heuristic way, we can achieve a distributed parallel framework in which all prosumers participate in solving the problem in a faster way, also keeping the information not disclosed. The way we accomplish this mission is by breaking down the centralized problem into many linear programming formulations and solving the resulting linear programming problems in a distributed parallelized way. So a new distributed optimization method based on linear programming is designed that overcomes previous methods based on integer and quadratic programming, such as alternating direction method of multipliers. The proposed method is scalable, allowing to deal with hundreds of thousands of prosumers in real time. It is privacy preserving. In fact, a global solution can be found without any prosumer knowing the behavior or objectives of any other one. It can be implemented by using the described architecture, where each prosumer performs an optimization based on its specific objective function. As regards with the distributed parallel linear programming based optimization, the idea is that of distributing the right-hand side of the global constraint among all prosumers by solving this optimization problem in such a way that the minimum power flexibility contribution of each prosumer is determined according to this equation by the energy reserve available in its battery. And we solve this optimization problem where the update of the parameter gamma is achieved in the virtual layer by smart contract. The basic intuition behind this formulation is that we increase the weights of gamma, of vector gamma, by a large amount on those constraints which are more violated. Now I will present some results considering at first the centralized optimization. More details can be found in this article. The studied large scale aggregate consists of 2,000 residential users, all of them endowed with a controllable photovoltaic battery system. And in this figure we can see the state of charge performance for a day in April in the case of up regulation for the whole aggregate. And in the lower part of this figure we can see the average power in a quarter of an hour related to the photovoltaic generation, the absorbed power for the baseline, this is dotted line. The absorbed power in the case of up regulation, this is this black one with the squares, where we can see that the up regulation is delivered, in this case, for 4 consecutive hours from 2 p.m. to 6 p.m. When looking at the results for 1 year, we can see the mean of the daily objective function of the aggregate for different amounts of the year in this figure, and the mean of the daily remuneration of the aggregate in the case with up regulation and up and down regulation during 1 year in this other figure. It is clear that from March to September, the participation of the aggregate both in up and down and only up regulation allows obtaining a daily remuneration that is higher than the daily cost related to the purchase of electricity from the network. And also when we look at the increment of energy cost for all prosumers in the case of up and down of up regulation and up and down regulation during 1 year, we can see that from March to October, the costs due to the energy absorbed by the grid are the same as in the case without regulation. In the case with up regulation, while in the case with up and down regulation, we have a modest, very small increase in this cost. Also, it is important to point out that the impact on the self-consumption, according to these results from photovoltaic generation, and also on the lifetime of the batteries is negligible. Now I will present some results obtained with the proposed innovative scalable privacy-preserving distributed parallel optimization method. More details can be found in this paper. Also in this case, we consider an aggregate of 2,000 prosumers that can satisfy the flexibility constraint of 1 megawatt. In this figure, we can see that up regulation is provided from 2 p.m. to 6 p.m. and we can see the difference between the centralized and the distributed approach. And we can see that if compared with the centralized approach, the proposed parallelized distributed optimization can achieve the same flexibility in terms of delivered energy in the mentioned period and the same value for the objective function. These are the results for day-ahead optimization. When we look at the results for the real-time optimization, and if we consider a day-ahead forecast error over 20% for the electrical load and over 10% for of a forecast error for the photovoltaic production, we can see here the absorbed powers related to the real-time optimization. It's worth noting that regardless of the forecast error, the parallel real-time optimization can achieve a power profile very close to that accepted during the day-ahead optimization, thus not incurring in any penalty. Now we can see here the computational time of the proposed approach, day-ahead optimization, for an increasing number of prosumers in the month of June, for example. And we can see that in the case of 40,000 prosumers, it takes a time lower than 2 seconds. Also, it's worth noting that we're considering the real-time parallel optimization. The computational time varies between 13 and 25 milliseconds, considering different days during the year. Now let's move to some final comments. And I'd like to highlight that the linear programming based parallelization enables not only to perform in an almost real-time way for very large scale real-world problems, but also to fulfill the privacy of prosumers. Both they are the real-time optimizations being highly scalable and able to protect the personal information of prosumers, overcome typical drawbacks of centralized methods. The proposed linear programming based optimization methods can be easily coded up and implemented on microcontrollers and connected to the implemented layered architecture. Here there is a list of for further selected readings on this topic. Thank you so much for your interest and attention. I would now be interested to hear from you your questions. If anyone like more information or has questions, please feel free to contact me by email.
Thank you a lot, Pierluigi, for your very interesting presentation. As I mentioned in your introduction, we have in this meeting people specifically working on the subject, okay, of your lecture. Particularly, we have Alessandro Burgio, who is involved in a project, in a national project, in the same area of your research. We also have Alessandro Burgio comes from university, specifically the department of is the DMEC department. Okay, it's management engineering and mechanical engineering. Even though he comes from a group that is specifically focused on power system from the smart grid viewpoint. We also have Carlo Mastroianni and Luigi Scarcello. They are from the ICAR Institute, and they also are working on similar topics. Okay, so I'd like to open, let's say, the dance Okay, and hopefully questions coming from Alessandro, Carlo, Luigi, but you know, please raise your hand and so that I can pass you the floor. Okay, Carlo.
Hi, Giancarlo. Yes, it was a very interesting talk, and actually, it is quite the same topic on which we are working. I was talking offline with Luigi Scarcello, and he was wondering the type of computer that you have there in Salerno, because we have a lot of problems for simulating hundreds or thousands of users. Can you give us some details about the computing infrastructure there?
Yes, thank you very much for your question. We are not using a particular kind of high performance computer because, as I have shown by yes, but if we consider the centralized optimization, it takes a lot of time, especially when we consider up and down regulation together. But when considering only up regulation, it is quite fast also the centralized optimization. While when we solve instead the optimization with the proposed parallelized optimization approach, as the mixed integer linear programming problem is breaking down in many linear programming formulations. This kind of formulations can be simulated in a very short time, as I have shown you. So essentially, we don't have in this phase of simulation specific requirements for the computational resources. But maybe I think when we go to a real application, I think it will be necessary also to carry out a more accurate analysis of the in order to define what is the best hardware, the best computer to use.
Okay, thank you. Anyway, we will have a look at your papers, so then probably we will contact you by email because we are very interested.
Thank you.
I don't know if there is some paper still to be published that is interesting for us, or everything is already published.
Yes, the papers I have shown you are the last ones we have published, and now we are trying to develop a new method because now in order to solve the linear programming optimization and also the mixed integer linear programming, we are using mainly MATLAB, but also we simulated it with CPlex. And in particular, when using MATLAB, we are using a specific function like linprog of MATLAB. We are trying to develop a new approach without using this kind of inbuilt function of MATLAB. But I think this will be published hopefully I hope during this year.
Okay, so the last question. So if I ask you to suggest one single paper in which your parallel approach is described,
yes, the last one in only we published in the last paper in published in IEEE Access. Okay. This is this one.
Okay, thank you.
You're welcome. Thank you very much.
Great. Okay, thanks.
Okay, thank you.
Thank you.
And anyone else? Maybe Alessandro or someone else?
Good morning, everybody. Can you hear me?
Yes, go ahead, Alessandro.
Okay, good morning, everybody. Thank you very much for inviting me to this very interesting speech. Hello, Pierluigi. We know
Hello.
each other in person. Okay.
Hi, Alessandro. We are in touch
I
with
really
Alessandro.
appreciate a lot your presentation. So my question is about the implementation of the models that you talked about, and the real world we have powerful computational results on cloud system at cloud level, and they are cost effective. On the contrary, at end user level, we have small computers with limited RAM memory. So my question is, in your opinion, and in the near future, what will be the right compromise between centralized and distributed computational reserves in order to solve the models that you was talking about?
Yes, thank you very much, Alessandro, for your very interesting question. In particular, we are focusing on this issue, and the proposed approach has been also considering this issue. And as you suggest, it is important not only for the reasons related to the computational requirements, but also for other issues related to the privacy of prosumers, to try to develop a hierarchical infrastructure and to share the computational efforts between the aggregator at a central level that, as you told, is as you told us, is endowed with powerful computational resources, and all the other prosumers that can be also thousands. And according to this idea, we think that I think that the best compromise solution can be that of sharing the computational effort between all prosumers with regards to their local optimizations, because each prosumer can have some available data related to, for example, the local photovoltaic production or its local demand, and according to this local information, each user can carry out a local optimization that, according with the proposed approach, it is a linear programming optimization that it's quite easy to solve also with a microcontroller that can be installed and can be at the disposal of each prosumer. And this local optimization can give as output some data that can be used at a central level to carry out the global optimization. In particular, the problem, the presented problem, as I have described, as a global constraint that allows that requires a form of coordination, as you know, among all prosumers in order to respect the global constraints. I refer to the constraints related to the power that should be the flexibility power that should be provided by the aggregate if compared to the baseline that should be for the whole period, should respect the value of 1 megawatt in the case of the UVAM in Italy, for example. I think by the right coordination between local optimization and centralized optimization, we can achieve the best compromise.
Thank you very much.
Thank you.
Okay, thank you, Alessandro, for your question. And anyone else would like to just ask something, curiosities, or Sharon, please go ahead.
Yes, I followed your talk with great interest, as well as some of the questions that were posed. In my experience here in power energy systems, in talking with them, both the ancillary suppliers or the main base load energy supplier, they say that their greatest problem is the response time, because it takes time to increase the base load or the renewable, distributed renewable in parts of their grid. So for every energy market, these are different. So when you do come up with a solution, you're right. A mixed model is best, where there's some central, some distributed, and using edge computing. If you would factor in the required response time, then that will help dictate the computational resources and solution time. So what do you think of that?
Yes, thank you very much for your question. I agree with you that it also depends on the time response requirements related to each specific market. With respect to these requirements, we considered for this reason as the only devices to give this flexibility power contribution of the battery energy storage system that, as you know, can exhibit a very fast time response due to the inverter interface.
Yeah, thank you. Yeah.
Thank you very much for your question.
Okay, so anyone else would like to ask something? Just some considerations or something like that? Okay, so I will save, the last question for me. So the questions were very interesting, specifically, from my personal perspective. The one, by Carlo Mastroianni, related to the use of high performance computing. So this is, in my opinion, important when you would like to set up simulation, okay, of such kind of systems, and involving a significant number of elements. Okay, so this is something that very likely should be supported by maybe next generation of simulators dealing with such kind of problems. Okay, we have the same problems when we deal with the Internet of Things, for example. If we have to simulate systems with a huge number of nodes, different kinds of nodes, the current simulators are not suitable, okay, to provide, let's say, results in reasonable times, or even to provide results, because sometimes they are not able to even provide any results, because there are issues in the simulators when the scale increases a lot with respect to the common scales according to which such simulators were devised and tested. Okay, I think that this could be an interesting research activity that could complement yours, because of course your research activity is at another level, okay, with respect to the use of distributed simulator, as the one I mentioned, related mainly to telecommunication area. Okay, but my question is more specifically focused on the privacy preserving. And what do you think about privacy preserving in this kind of systems, and which kind of privacy we need to preserve in this kind of system? Because in my research area, I deal with privacy related to wearable computing systems. That is pretty different in my opinion, but also generally speaking, privacy at the IoT system level. And sometimes we use also blockchain. So may you detail a little bit which kind of privacy you are going to preserve in your systems?
Yes, yes. Thank you very much. So I agree with you that regarding to your first comment, there is a lot of work to do, also in collaboration with expert in distributed simulation in distributed systems for carrying out this kind of optimization, and this can be a future work. As regards with the privacy issue, we consider that a single prosumer would like not to disclose its use of electricity during the day, or other data related to its, for example, use of the battery energy storage system, or related to the production from the photovoltaic system. So, in this, according to this consideration, we consider that in the proposed approach, the only information that is disclosed and that is used at a central level is its power exchange with the main grid. Also, only the power at the interface point of connection is communicated by each prosumer. No other information.
Okay.
And also, as you suggest, it can be also stored, this information, in such kind of blockchain, and in a smart contract, in a distributed ledger.
Okay. Yeah. We discussed it a little bit, by phone recently.
Yes.
Indeed, we also are working on blockchain from distributed ledgers viewpoint, specifically running on lightweight devices. Even though, in this system, very likely you could not have any problem with, let's say, heavyweight devices instead of having lightweight devices. So I'd like to understand a bit better this viewpoint, because again, I'm not a domain expert, so I don't know very well issues related to privacy in these systems, even though I can have some, let's say, intuition. Okay, but I guess that the methods and even the methodology you are using could be reused in a different context, in which you don't have, let's say, power systems, so smart grids, but you could have networks of smart objects, for example, in different domains, or even networks of wearables. And then you have to preserve the privacy of the whole network, and specifically even of the individuals with respect to the whole networks. And I guess that the issues are pretty similar. Maybe, of course, we need to let's say customize or something like that. The method, okay, but I guess that the methods could be reused and then customized for other application domains. What do you feel about this?
Yes,
Could
yes,
they?
I think.
Yeah, could they? Okay, please.
Yes, I think you are right. Both, I think the optimization, the distributed parallel optimization approach can be used to different in different domains, like the one you have described, and vice versa. Your technologies and methods can be used to solve the power system problem. My question is, do you have, in the case of wearable devices, the case where each device should carry out some kind of optimization?
Yes, this is, our research, in the sense that currently available wearables, usually they don't perform any computation, embedded computation, just very simple one, because even though they got, in my opinion, capable enough MCU, they are much more, devoted to collect data, pre-process them, and then send such data onto some cloud system. And then on the cloud system, some more computation will be performed. Okay, but on the other hand, our vision is that the wearable devices could compute much more than what they are able to compute now. Okay, so very likely in a near future they will have more computational capabilities, and then they could also run optimization algorithms inside, machine learning algorithms inside, without using any cloud computing platform, or even interact with some edge computing platform. So our idea in the near future is to use edge computing, okay, or fog computing, in order to support more computing intensive tasks, okay.
Yes.
And also even more computation inside.
Yes,
Okay.
that's a very good idea, I think. Yes.
Okay, thanks a lot,
Yes,
for your answer. If there is no one else, okay, so we can say that it was a very pleasure, to have you here in our lecture series. Very nice talk, inspiring one, because in my opinion there are many common aspects, specifically, and also, as we mentioned a couple of seconds ago, maybe we could find some application of your methods in a different context. Okay, different from power system.
Yes.
So thanks a lot once more. And before we say goodbye, I'd like to say that just show you the next talk, the next lecture.
Thank you very much. Thank you very much.
Thank you, Pierluigi.
Giancarlo and everybody for attending this lecture.
And thanks to you. And the next one will be next week. Let me show you. Is January 22, so next Friday. And will be a very different one. Maybe, unfortunately, it will be, you know, a very hot one because we are still in a pandemic period. Maybe we need at least 6 months, maybe after summer, in order to see some real light about this pandemic. And the talk will be on contact tracing, and with a different perspective. Okay, very different from the perspective on which many different apps, including Immuni, the Italian one, you know, sponsored and promoted by our government, were developed. So the perspective is different, very interesting. I had a talk with Professor Poshen Law from Carnegie Mellon University, and we decided, you know, to organize this lecture. And I hope that you will find it very interesting. Again, it's a different way to build a contact tracing deployment. Okay, very different. And I hope that you can participate. Of course, we will advertise this lecture, and I hope to see you next Friday. Once again, thanks a lot to Pierluigi. Thanks a lot to the attendees, and see you next week, next Friday. Okay, bye bye to everyone.
Bye bye. Bye bye.
Bye, everyone.
Goodbye.
Goodbye.